Hello students, welcome to Sree Academy. Now we are going to discuss the digital electronics questions which came in 2025 ECET, AP ECET, and we will go through this is the paper questions, all digital questions along with the important points also, so that you can attempt 2026 paper digital questions easily. You see what way I am going to solve the paper also, questions also, and whatever the points you don't know, you please note, that will be definitely helpful to you. So we will see the first question. This is a starting question of digital electronics paper. I mean, it's not separate paper. Within the paper, wherever you got the digital question, this is the first question, as I observed. Okay. So he is asking which type of the gate shown in the figure it is. So this is a construction he has given. He is asking what gate it is. For this, you really required to solve the expression. You can land up with the solution. Okay, how to solve? With you do not require higher knowledge also, because you will be provided 1 minute of time. Since NAND gate both inputs are shorted, this will act as a just NOT gate. So you will be getting here A bar. Simple. Okay. B, when both inputs are shorted, this also works as NOT gate, so that you got B bar. So this NAND gate got the inputs as A bar and B. So the output will be A bar and B. Since bubble is there, whole bar. Okay. And this NAND gate output is A is there, B bar is there. So which is AND gate output. Bubble is there, that's why one more bar. AND followed by bubble, which is NAND. Okay. I did first AND, then bubble. Now this is one more NAND gate output is there. Here how should I write? X, Y, whole bar. X dot Y, whole bar. X is this, okay, which is A bar B bar dot, that is X, quantity X, quantity Y, which is A B bar whole bar. This is X dot Y, resembling X dot Y whole bar, because this bubble is there. Bubble is there. So now using De Morgan's law, I am splitting the above bar, then it will becomes what? A bar B bar whole bar, this dot is becoming plus, then this is A B bar whole bar, whole bar. This bar and bar jump, this bar and bar jump, both NOT gates jump, then you got A bar B plus A B bar, which is B bar A. So you can tell what gate it is now. It is not that difficult. Only he asked you whether you know this is NOT gate or not, this is NOT gate or not, and whether you know X by, and De Morgan's applying whether you know or not. De Morgan's what it will tells? De Morgan's law what it will tells? De Morgan's law what it is telling to us? X plus Y whole bar is there. If you want to split it, that will become X bar dot Y bar. So this becomes plus, becomes dot. If you have X Y whole bar, if you want to write it, X bar dot will become plus, X bar dot Y bar. That's it. Here X dot Y whole bar is there. That's why X plus Y bar I did. One thing I applied, this I got. So answer is XOR gate, A bar B plus B bar A. Answer is A bar B plus B bar A, which is XOR gate output between two inputs, A comma B. So like this, very simple questions are there in total paper. You will see, you will definitely feel digital 10 bits out of 10 bits I will catch. That kind of feel you can get by seeing this total video. You stay tuned with me. We will see the next question. Full adder can be implemented by a twisty way. He asked this question. You please go through. Decoder. Decoder alone you cannot realize a full adder. You need plus one OR gate also. Then you can realize. AND gates and OR gates, never you can realize a full adder by using AND and OR. You need extra XOR gate also here. So XOR gate and OR gates and NOT gates and NOT gate also required. Then you can realize full adder. Then you can realize full adder. Full adder with simply with gates. Full adder with one block. Block is decoder. If you have a decoder plus one OR gate, then you can realize full adder. Plus one OR gate. Okay. Off adder. Off adders alone you cannot make the full adder. Off adders plus OR gate also required. Two off adders plus one more OR gate is required to make a full adder. but multiplexer alone you can make a full adder. Multiplexer alone, because here now you understand the subject. Decoder follows, here I am giving decoder follows only AND logic and inversion logic. So this decoder will have AND gates, NOT gates in the block, AND gates, NOT gates inside the block. Okay, so here XOR gate may not be required. Of course, you can, if you have NOT gates, you can realize XOR gate is not that necessary. XOR gate is nothing but combination of AND and OR. So NOT is there, then you can make. Okay, so if you see, decoder is nothing but club of AND gate followed by NOT gate. So AND NOT already there, unique-wide OR. Here is specified AND OR, but NOT gate is not there, that's why you cannot. If you see half adder also club of same. Okay, AND gate, NOT gate is there, OR gate you require, that's why this is. But multiplexer, if you see, it will follow AND OR inversion logic. That will follow AND OR inversion logic. That means what? It will be having AND gates inside it, it will be having OR gates inside it, it will be having NOT gates also inside it. So it can realize any Boolean expression without any external gates. That's the reason why you can implement full adder, you can implement half adder, you can implement any Boolean expression by using multiplexer alone. That is the beauty of multiplexer and king of combinational blocks. All blocks, decoder, encoder, demultiplexer, all code converters, all are Boolean expressions only. That Boolean expression, actually, that is the beauty of multiplexer alone. That is why in our VLSI designs also, if you see FPGA, in the FPGA what it will be there? One mux followed by one delatch. One mux followed by one delatch. It will be like one 4x1 mux followed by the output will be taken into a D flip-flop. D, this is Q output, and it will be clocked. So here you will be having 4 inputs, 2 selection lines, 1 output. This itself is called as one block. One block. So like this, so many will be there in your FPGA to realize all Boolean expressions. All Boolean expressions. So multiplexer is king of all your combinational designs. Tricky question, you should know what is what. For this, you need to attend full course of the digital electronics. Then when we explain each block, you will be getting all the points out of that block. Okay, stay tuned, we will move further for next. What is the dual of A plus B plus A dot C then plus D? Oh, such a kind of questions actually teacher not required even. Coaching is not required to. Simply dual means what? Plus 2 dot dot 2 plus 0 to 1, 1 to 0. Again I am telling what duality is telling to us. Duality tells 1 to 0 and 0 to 1 you change. Okay, and plus to dot and dot to plus. This is what you have to make. That is what is duality. Write the answer directly, simple. Wherever plus is there, you make into dot. Wherever dot is there, you make into plus. Simple. So I am writing the answer directly by starting with a variable whatever is given. Solution. A is there, I am writing A. Plus is there, I am making it dot. Dot is nothing but open bracket, dot. Okay. Then B is there, touch the B. Okay. Then plus is there, you make bracket. A dot C is there, make it A plus C plus 2 dot. Bracket close. 2 times bracket close is there. Okay. Over. Plus is there, dot, that's why bracket. Plus is converted to dot, into D is there, D. This option wherever it is there, that will be the final answer. A over B over A plus C of D. So this is the correct answer. A, B, A plus C, D. Over. Simple. Plus 2 dot, dot to plus. We'll go for the next question. NAND gate with positive logic will operate as. This is a sentence oriented question. NAND and OR are couples. NAND OR. In the same way, NOR and is coupled. Positive logic and negative logic, there is a inversion between coupling of two logics. Okay, basically we will be having AND, OR, NAND, NOR. What I am telling, positive negative logic inversion between these two. Now what he is asking? NAND gate with positive logic will operate as negative logic in what? Negative logic in OR. So where it is? OR with negative logic in it. So this is your answer. If you remember this much, it is over. Then what is positive logic? What is negative logic? Positive logic means basically we see this is 0 volts is nothing but logic 0. 5 volts is nothing but logic 1. This is what we call as positive logic. Positive. Then what is negative logic, sir? Basically the same. 0 volts is nothing but logic 1. Logic 1. 5 volts is nothing but logic 0. Reverse. Where you are telling, it will be 0. Okay. This one we call as negative logic. Negative logic system. If you want to change the system, it will be doing like this. Okay. We will move further. We will see the next questions. How simple are they? Like this. Just theory oriented questions only. I don't find much mathematics are involved in this. I don't feel to. It's very simple questions only are there. The main advantage of CMOS over the TTL circuit is, CMOS is basically low power consumption device. That's why we are using in our VLSI technology. All the CMOS. We are doing all the circuits with CMOS only. Where TTL is required in the sense high voltage levels. Okay. High voltage levels. Delay will be less also. But here delay will be more. Propagation delay will be more in CMOS. Slower in nature. TTL is little faster in nature compared to CMOS, faster operation. Okay. I explained in a TS paper also, in the same year, Telangana question paper is asked about logic families. There I explained how CMOS will work, TTL will work, what is the difference between those two, which one will be benefit to us. All those things I explained. You can refer to that video also, basically. Here I am going through minimum points, whatever are required to cover this question. Okay. Extremely low cost, advantage of TTL. No. Increased speed of operation. CMOS is nowhere faster than TTL. Much reduced power dissipation. This is correct. Power dissipation is less in CMOS. TTL, it will take more power. Very small physical size. No, it is not in small size compared to TTL. So, power wise only it is advantage for CMOS. In all the case, TTL is better. This is a theory oriented question only, no mathematics. If you see once or twice which family is fast, which family is slow, which is having more fan, which is having more fan in, all those things, if you have once a glance before going to exam, 5 minutes if you read, you can put a bit. It's not a mathematical bit, no, you need not to do so much solutions also, so much knowledge also. Bhatti also not required. If you see and go into the examinational, that is enough. Okay. Emitter coupled logic, the switching speed is very high because, this I will explain basically. Emitter coupled logic, TTL logic, both comes into bipolar only. Bipolar in the sense they will made with transistors only. This is transistor only. Bipolar devices. Okay. This TTL, wherever you are taking open collector outputs, they are also faster. ECL when you take emitter coupled logic, that emitter coupled logic is nothing but a differential amplifier case. You will be taking two transistors, which is going to be your differential amplifier case. Differential amplifier. One of the output you will be taking either from here or from here. Anything is okay. That depends upon NAND gate and NOR gate output technology. So these are going to be your inputs. Let's say this is A, let's say this is B. Okay. This is how your circuit will form. Say this is high, this is low. Basically, we will be giving here minus VEE, here plus VCC. Okay. This kind of circuit you will be having two transistors. When one fellow is turning on, other fellow will be turning off, and one fellow will be operating in active region. Active region, not in saturation and cutoff. But whereas in TTL, this fellow will work in on karna bole to, means when you want to turn on the transistor, it will be operating in saturation region. When you want to turn off, this is for what? On. When you want to turn off the transistor, it will be in cutoff mode. Cutoff mode is for off. Now here it is not like that. Here it is not like that. Both the transistors will be working in active region. When active region is getting performed in the transistors due to your input and circuit topology, okay, here you can either implement a NAND gate or you can implement NOR gate. Here TTL you will be implementing only NAND gate, which is slower in nature because you have to think, like this, you have to jump in between. If you see the transfer characteristics, if you see this as the transfer characteristics, if you, let's say this is on condition, let's say this is off condition, and this is your linear region. Linear region is more faster than on region and off region. If you want to go from here to here, it will take lot of time. But other transistor will be in like this condition. So they will be operating between these areas. One is on, one is off, one is on, one is off. So making on off between these two fellows is very easy, dead easy, like a op amp comparator things. Okay, so this is very easy, that's why it can be operated more faster because they are operating in active region, not in saturation and cutoff. When you consider totem pole transistor, a single transistor with base, collector, emitter, single, then here the transistor will be operating in either on condition or off condition, not in active region. Okay, that's why this is slower in nature. Okay, due to faster operation, loss also more, power dissipation also more. Correct? It is speed, but switching is more. Due to more switching, more power dissipation also there, but very fast. Advantage also there, disadvantage also there. We will see. Emitter coupled logic, the switching speed is very high because, why it is high? Because it is operating in active region. Whether that option is given, the transistors are not saturated when conducting. Yes, this is correct. The transistors are not saturated when conducting. During conduction, that is in active region, not in saturation region. Okay, that's what he told. The transistors are not saturated when conducting. That is correct option. Emitter coupled transistors are used. Emitter, that is already told. Multi-emitter transistors are used. Not required. Multi-emitter is not required. Single inputs are also enough. So this is the advantage. Not saturated when conducting. This is the correct answer. If you know this much, you can give. Now you can solve TTL also, ECL also. If this question arises again, it will be very easy to you, and you know what is best in ECL, what is not best in TTL. Both are same family only, TTL and ECL. We will see this question. Minimum number of comparators needed to build a 6-bit simultaneous A to D converter. Ooh. This simultaneous A to D converter is nothing but parallel type. Parallel type. Parallel type. This parallel type will actually works with number of comparators and number of resistors. You have to make a resistive division. If you want to compare 4 bits, converted the 4-bit digital data into analog data, then you require 2 to the power n minus 1 comparators and 2 to the power n resistors. So in parallel type, you will be using number of resistors for resistive division. Number of resistors. This is 2 to the power n. Number of bits, where n is number of bits. And you will be using number of comparators 2. Comparators 2. The comparators number is 2 to the power n minus 1. The power n minus 1 number of comparators you will be using. So now you can answer the question. This is the parallel type. He is asking number of comparators and he is asking 6-bit, where n is equals to 6. So if you use this formula, the number of comparators, the required number of comparators is going to be 2 to the power 6 minus 1. that is nothing but 64 minus 1, which is 63 is correct answer. So if you ask number of resistors, this formula you use. If he is asking number of comparators, you use this. Okay, the answer is going to be now 63. That is first option. Very nice. First option only he has given the answer. So like this, very small things he is asking. If you know little broad information about the context, you can answer it basically. For this, no need of topper or first ranker or second ranker. If you know broad information, you can put the bit. Digital is such a easy subject for ECE guys. Than this, no other subject you have which is easy to you. All are very vast. In digital, you are having 2 to 3 topics only. One is Boolean algebra and simple number system. Second is just combinational designs. Third is sequential designs. Within 3 topics, all are related only. Simple relations. If you know that much, you can answer. 10 to 11 bits you are having. Okay, very easy. If you have cumulative information over the subject, you can put the bit. Okay. If you want more information in this digital, please subscribe. You watch the videos. You follow us. You will be getting 10 out of 10 in digital. There is no question at all. If you see this question, the figure of merit of any family, you take any TTL, ECL, anything, any logic family, I square C logic, anything. Okay, any logic you take, DTL, RTL, all these logic families, we can make some standard gates like NAND, NOR, standard gates you can make. Out of that, how will you tell which is good, which I want to take? That is depends upon FOM, figure of merit. Figure of merit. What is meaning of figure of merit? So when you are choosing a technology, you should be familiar with 2 things. That is nothing but speed, power, product. Speed in the sense propagation delay, power in the sense power dissipation across the IC. This is only called figure of merit. How speed it is getting operated? In the previous question, I have explained. When ECL logic is getting operated on to off, there will be very fast enough because it is operating in active region, and I told you there will be power dissipation also because it is operating more, it will dissipate more power. Okay, that only I am explaining this question now. This power dissipation and speed, multiplication of that, whatever the number is coming, that only we call as figure of merit. More the figure of merit, lesser the figure of merit. Like that numbers you have to take into consideration. For a proper operation, power dissipation should be less. TPD, delay should be less. This is lesser, this also should be less. Lesser the speed, not speed in the sense propagation delay. Speed is depends upon propagation delay. Lesser the propagation delay, it will be more speed. Lesser the power dissipation, power handling capability is very good. So this should be less, this should be less. So total figure of merit ratio product should always very less number. Then that IC is more useful to us. That's what you have to catch here. Speed power product in the sense. What he told, what is it only he asked. Okay, sorry for. So this is nothing but figure of merit. FOM is nothing but propagation delay times power dissipation. That itself is the answer. Simple, we already discussed it. Okay, we will move for the next question. Like this, very conceptual questions, easy questions. If you know concept, you can put. For this, nothing is required. No, speed, power, product. What is there? How speed it is? How dissipation it is making? Simple. A 10-bit ADC has a range of -5 to 5 volt. The resolution of ADC is approximately. Resolution is nothing but step size. Resolution is nothing but step size. Resolution is nothing but step size. What is step size? We will tell reference voltage divided by 2 to the power n. 2 to the power n. Number of steps. This is total voltage divided by total number of steps will give you 1 step voltage. Okay. It's like 10 bananas, 10 students in room. One person, how many bananas he will get? It's like same question only. Total voltage divided by total number of steps. Total voltage he is telling -5 to 5. Don't make any mistake here. He told there is a waveform between minus 5 to 5. So your voltage level is minus 5 to 5, your 0 voltage is here, minus 5 to plus 5 is here. So total voltage is 10 volt change. It's a two-way signal, sine wave with a negative and positive, or triangular wave with negative and positive. So minus 5 to plus 5 peak values. So the peak maximum value is nothing but Vref you have to consider as total voltage, V dynamic. So I can still even tell Vref instead V dynamic. Dynamic voltage of the full signal divided by number of steps. V dynamic range is nothing but total voltage. Here it is minus 5 to 5 is nothing but 10 volt change. 10 volt change divided by 2 to the power n. N is a 10 bit he given, 2 to the power 10, which is 1024. Okay, that's going to 10 divided by 1024. Approximately how much? 10 divided by 1000. I am considering it as 1000. So lesser than 1 it will come. Correct, no? 1. So 9 around. So 9.5, 9.6 range you will get. This you can divide. It's something around 9.7 millivolt. So approximately you can make it as 10 millivolt. 9.7 or 9.6 it will come, I think. 10 divided by 1024, which is around 9.7 to 9.6. So I am approximating it to 10 millivolt, because then you didn't mention anywhere. 10 millivolt option is given. That's first. Okay, simple only. Like this you can solve. If you know concept, it will be easy. If you take plus 5 or minus 5 alone, the answer will be different. So please consider, because then you will be falling at problem. What is the minimum number of JK flip-flops required to realize a modulo synchronous counter? Whether it is synchronous or asynchronous, whether it is JK flip-flop or T flip-flop, number of flip-flops you will be requiring is definitely will require upon modulus is always less than or is equals to 2 to the power n, because this is the number of counts, maximum counts. Modulus is nothing but what? Number of counts we will be having at the counter. Okay. Example, if I take 3 flip-flops with me, I can start my counting with 0, 0, 0 and I can end up with maximum 1, 1, 1. Okay. This is nothing but you are counting from a 0 all the way you are counting up to 7. This is the maximum count that you can make. Okay. Out of that it is not possible. 8, 9, 10, that is not possible. Okay. Maximum count you can see up to 7. So that's what. The maximum count is always 2 to the power n. Here I got 8 possible values. 8 possible values, that is 2 to the power n. Modulus is nothing but where you want to stop. How many values you want at the output. Whether you want 8 or whether you want only 2, whether you want only 3 or whether you want only 5, that's up to depends upon you. When you select a number of flip-flops, the maximum count is always fixed. That is how much? 2 to the power n. This is fixed. Out of that, you can make equal to that, which is modulus is equal to 2 to the power n, or else modulus may be less than 2 power n. So I am writing less than or 2 to the power n. So now he is asking JK flip-flop or T flip-flop, whatever it is, modulus 5 he is asking. With 2 flip-flops I can only count from 0 to 3. Means only 4 states. 0, 1, 2, 3. If I have 3, I can count from 0 to 7, which is 8 states. Mod 5 also I can generate, which is 0 to 4. 0 to 4. I definitely require minimum 3. Or else you put here, mod is telling 5. And you substitute n values, 2 power n. Number of flip-flops, how many you require? Let's try. Let n equal to 2, let n equals to 3. When n is equals to 2, what will happen? 5 less than or equal to 2 power 2 is 4. 5 is less than 4, 5 is equals to 4. Not correct. If you put n is equals to 3, 5 less than or equal to 2 power 3, which is 8. 2 power 3 is 8. 5 less than 8, yes, 5 is less than 8. One condition it is getting satisfied, that is correct. 5 is less than 8. So your minimum number of flip-flops you required is always 3 for mod 5 synchronous or asynchronous count. So like this, if you know this basic concept like this, you can answer. Formula also you need not to remember at all. You stay tuned with this app and academy videos that will make you very easy to understand the subject. Actually, what is counter? Now you understood, no? When I make 3, that will be like this. You know 000 to 111, but when I represent with boxes and it is going from here to here, you will understand little in a easy manner. Yes, this is a flip-flop. This is a flip-flop. This is a flip-flop. Simple. When 3 flip-flops are there, yes, they can alter their states and they can go from all zeros to all ones. Like this, if you basic things, if you are fulfilled with all combinational designs and frequential designs, you can put a bit very easy in ECET. 10 questions you can easily get. This question you see. 1 megabyte is equivalent to 2. Wow, what a small question he is asked. Simple. Here we know 4 bits are called. Stay tuned with Sree Academy. All the information will be conveyed to very easily and in a rememberable fashion. 4 bits are called nibble. 8 bits are called as combination of 8 bits. Okay. 8 bits is called as a single byte. 1 byte. 8 bits is nothing but 1 byte. 1024 bits is nothing but 1 kilobits. 1024 bytes is nothing but 1 kilobyte. Okay. 1024 is nothing but 2 power 10. Okay. 1024 multiplied by 1024 bytes is nothing but 1 megabyte. That is nothing but 2 power 10 and 2 power 10, which is 2 power 20 bytes, is called as 1 megabyte. So I am telling here 2 power 10 bytes is 1 kilobyte. That's what I told here, 1024. 2 power 20 bytes, 1 megabyte. 2030 bytes, 1 gigabytes. 2 power 40 bytes, 2 power 40 bytes, 1 terabytes. So if you have basics, we actually call our memory card size, no? 1 GB memory card, 2 GB memory card, 500 GB, 512 GB, 1 TB. TB is nothing but terabyte. Okay, like this, if you have basic information with vocabulary, he has given a mark in ECET. If you know the vocabulary, how we are pronouncing, what actually they meant, if you know that field, you can put a bit 1 mark, you can score in ECET. This does not ensure any mathematics you should know, does not ensure so much books you have to refer to. Vocabulary, just field free engineering, what we call, if you know to be an engineer, you should know basic things in engineering. If you know this, you can put a bit. How easy it is. Like this, every question is basically given in an easy manner in ECET. So if you understand questions and all these concepts, please subscribe our app in Play Store. Also our app is there, Sree Academy ECET. You please refer to that, and any subject queries are there, you also can post. Please subscribe our channel. Thank you.